Hello and welcome back to the Max Runout YouTube channel. We're back with our part 4 of our series on making gears in the home shop, and we've got our little box that has all our electronics in it, and it's all packaged up now and ready to go. And but the experience was a little more painful than I expected. When I did the software the first time on the development board, everything went incredibly smoothly. I guess I got a little overconfident, but pretty much all the bits of software and the control functions for the motor all went pretty much exactly the way I expected, and I really enjoyed that. And then I went to redo it in this box, and that was a little harder. The situation is, when I ordered some more processor chips for the thing, the ones that I was using were marked as not recommended for new designs. That means it's getting a little old and they may not keep it around forever, so I thought they recommended a newer processor with lots of new features and capabilities, and so I said, what the heck, let's go with the latest and greatest. So I upgraded to the new processor, and that was fine. But then of course I put the processor in a new board that had different I/O pins, so the software had to be changed to compensate for that. The new board runs at 20 megahertz rather than 8 megahertz, so that's 2.5 times the speed. And of course there's a lot of new wiring and connections, and so I made all those changes all at the same time. And after all these years, I should have known better. Do one thing at a time. But the outcome was that I had to use up my entire inventory of cuss words for this project, and not one of them made any difference at all. But eventually I got it all straightened out, and but it's a lesson that I've learned over and over again in my life. Do one thing at a time, and you'll be a whole lot better. So I'll give you a quick demonstration of that, and then we'll go on to getting it set up on the mill. Okay, so here's our little box and our motors, and motor 1 plugs into here, and motor 2 plugs into there, and our 5-volt power supply, little wall wart job, plugs into here. And now you can see the table light up, and the display light up, and the first choice you have to make, the table move. And by the way, it now remembers the move from last time, so it's got a little easier. This is our safety switch here, to prevent runaway on the mill. If you remember, I showed you that. I think it was part 2, and that plugs into this dangle wire here. So now we got everything connected. So it's just a matter of this is the button arrangement I got. I think if you remember, these are the buttons to set the numbers up and down. I've set it for 1 inch now. I can make it say 1.2 inches. And this is the next button, which sets you for the next choice here. Set the tooth count. I have it at 21 now. And again, I can use the up and down buttons to adjust the tooth count. And then the next button, again, it now says reminds me to set the table at home and go when ready. So the green button obviously is the go button, And so now you can see the motors are turning, and this is we're moving the table forward to do the cut, and it stops and it moves the table back to where it was, and then adjusts the rotary table for the next cut, and continues. And the next button here is the halt button. So if I hold the halt button down, I can start anytime I want, but if I hold it down when the second motor is running, it will then halt at the end of that cycle, keeps the tooth count to go at 21, and hopefully you can see that on your screen. As I learn about video, I realize how important lighting is. But anyway, then if you can halt the thing, you can reset the table, you can do a variety of different things. But this motor here stays engaged so that it holds your place, and you don't have to worry about being off on the next gear. Now I'm going to make one change to the software. I'm going to have this M1 be de-energized during this period, so that if you have to change the position of the table a little bit, you can. But then again, when you hit the green button again, it'll continue doing what it was doing, but it will stay accurately engaged in the right tooth position, so you don't lose that. And then there's the big red button. No matter when it is, if you hit the big red button, if there's an emergency, you can shut everything down, and then of course in that case you do lose your position, and because your motors are de-energized now, you don't want them to be running. Now, one important change that I made, by the way, I told you last time that I was going to put a relay in series with the power supply to the motors that would open when I hit this button. And after talking with the Technic guys, I found out that's a bad idea. The motors store a lot of energy in their coils when they're running, and if you interrupt the power to them, you can get a hell of a surge and probably fry your relay more than anything else. But it's just not a good idea to interrupt power to them in the middle of a move. So what they suggested and what I implemented was I cut power to the enable line on the motors, and that way they stop, and you don't have this big transient problem. The big capacitor in the power supply, if there are any transients, that all gets absorbed by that capacitor. So that's a better idea. So now if you've done that, you want to reset, start over again, and again you got to make your two choices, and you're ready to go again. Whoops, I have pushed the next button here. Oh no. Oh, I know what happened. The big red button is still engaged. So let's do a reset again, and we'll pull the button out, and now we should be ready to go. So green button to go. There we go. Now we're running. Now I just want to show you that the same thing happens if your table overrun for something. You may be off doing something else and not be there to hit the button if something goes wrong. If either one of these two buttons gets struck by the table thing, the same thing happens. It'll shut down, and then you'll do a reset again, and then correct whatever problem you have, and you're ready to go again. So that's how the thing works. And now the next step is we're going to take it over to the mill and start mounting the motors. And okay, we're at the mill now, getting ready to set up the rotary table. And this originally had a crank handle on it, but I've loosened the bolt on that, so that'll come off. And we've got to adapt this for use with a pulley. timing belt pulley like this so that we can control it with the motor. If you can see this shaft, it's kind of an odd arrangement. It's got a flat on two sides, and it's got its normal round on this side, and it has a keyway up here. And so I had to make something to deal with that, and this is what I came up with. It's a little part, just a little part I made on the lathe, and see, can I get that? There it is. And it's got set screws on three sides. One of the set screws will come down on the keyway here. I'll put a little, I got a little chunk of aluminum I made to fit in there, and the other two set screws will come down on the flat spots, and that should give me a nice, a good fit here. Okay, we've got the adapter on there now, and now the timing pulley fits on here, and you see I got a flat spot cut there also for the set screw of that to bear on. There that goes. Get that right on the flat. So that's ready to be driven by the motor. Okay, now we're going to square this up. We got some clamps put on the front of this the table, and we'll square this up using a carpenter square here. Good enough for this job. Doesn't have to be precisely square, but I like to get it as close as I can. And now we can tighten down these clamps with a 7/8 wrench. And we will line up the tailstock the same way we did in part one, with an indicator on the spindle of the mill. Okay, we're gonna remount these motors, get them off this piece of wood, and put them on those aluminum angles that I showed you before. But before I do that, I want to say a word or two about these pulleys that are now on the floor. These are called Shaftloc pulleys, and I chose them because I did not want to mess up the shafts on these motors. I plan to use these for many other projects, and versions of this perhaps. And they have a keyway in them, but I couldn't find any pulleys like this that were keyed, that were the right size to fit these. And this is a mechanism that comes with the pulley. Well, you actually buy it separately, but it's a pretty clever little mechanism that as you screw these two pieces together, the inside diameter compresses to grip the pulley shaft, and the outside diameter expands to fit tightly in the pulley diameter. So the combination gives you one. It doesn't sound like it would lock well, but boy, it sure does. it fits really tight on the shaft, and the combination really holds well and makes for a good smooth connection. This one's tightened up here, but let's put it together. This part slips into the pulley, and this part screws on the back. And you slide this over your shaft. Now, one difficulty I had was that none of my wrenches was thin enough to fit in there to tighten the thing up, and so I had to make my own wrench. This is one I just made a quick cut with this is a scrap of steel that I had, and I made a cut with the milling machine into the end, and then I just kind of crudely filed these out. So, but it does the job. So that'll go in there and grip that side of the nut, and we tighten this up. Make sure we're not still got enough clearance there. Now we got a nice grip on this pulley, and works really well. One other thing about these pulleys, I got them from a company called Stock Drive Products. They're a good source for a wide variety of drive things. They got shaft couplings and of all different kinds, flexible and otherwise, and they've got gears and pulleys and you name it. But one thing about their website is a little confusing. These are, known as timing gear or timing pulleys, and if you look for timing pulleys on their website, you'll never find these. They have some specific kinds of timing pulleys, and it's not clear how to find them, but these are called Shaftloc pulleys, and if you look on their site for Shaftloc, and they have another style called Fairlock, although I couldn't find the size I needed in that style. But if you look for that, and I will leave a link in the description here that will take you right to the Shaftloc section, and you can buy the little inserts here, and then generally if you pick an insert, then they will have a link to a pulley that matches that, or a series of pulleys that match that. So that's the way to find that. I was pretty happy with the service and so on I got from them. Okay, we're getting ready to remount these motors onto the angle brackets we made earlier, but this motor has a step in it for a reference surface, and you got to make sure you make the hole in your bracket bigger than that so that it fits. And the pulleys that I have happen to fit through it too. Now, what I wanted to point out here is that there's not a lot of room on the back here for a nut. I got some there we go. Got some 1032 flathead screws because they fit pretty nicely into the size of the holes in the motor. But the problem is that a standard size nut, like the bigger one here, is a standard 1032 nut, and it doesn't really fit in the space behind that's available behind the ear of the motor. But you can get what's called small pattern nuts. I bought these from good old McMaster Carr, and they fit fine in the space available. So I could put them together just like this. that combination works real nice. So we'll put the rest of these together, and then we'll meet you back over at the mill. Okay, getting ready to mount the motor on the first motor on the mill table, and this is motor 2. No, I've been calling number 2, and it's the one that will be driving the rotary table. I think you can see that. Yeah, right. Okay. And so I got 2 strap clamps already turned into T-nuts like these in the slots of the mill table, and we put these over here, get them on top of the motor. It's not going to go anywhere. And the front of these will be on this, which is a 1/4 inch thick, and in the back I've got another 1/4 inch plate, and I've slipped just a shim under here. I think this is, I don't know, about 12 thousandths or so thick, and that guarantees that the back of the clamp sits a little higher than the front of the clamp, so I'll get good clamping pressure on here. Now here's the belt that's going to drive it, and we got to get close enough here so that belt fits on, and we also want to get, well, we want to be square here. I'll check that with the square in a minute. And we need to be far enough out so that the belt lines up pretty well with the belt on the on the rotary table. And we'll put a straight edge here on the rotary table belt, and we'll get the one on the motor to line up with that. Okay, we're lined up that way. Check to see if we're square. Hey, pretty good. I couldn't do a whole lot better than that. And now, of course, the belt tension. Okay, let's do a preliminary tightening on these. Okay, they're both finger tight now. Let's double check again for squareness. Looks good. And alignment looks good. I think we got it. So I got to tighten this up with a socket wrench. So, well, the one of them anyway. This one I can tighten up with a end wrench. Okay, the other one needs a socket, so I will get that and I'll be right back. Okay, we did that off camera, and now we're nice and tight in here, and we seem to be working the rotary table okay. So the next step is going to be to mount the motor that will drive the table back and forth, and we'll reset the camera for that. Okay, now we're going to mount the motor that's going to drive the table back and forth. And in order to do that, I had to take off the handle assembly, which the handle had slid back and forth on this bushing so that it could disengage with the assembly, so it wasn't driven around all the time. But I guess that was part of the power drive for this thing. But anyway, I had to take these 2 pieces off, and so I had to make 2 spacers. This one out here makes up for the extension here, and there's also an extension in the back which you can't see, but there's another spacer I had to make that fits inside there so that the gear would fit up tight to here and I could tighten this nut. You got to keep the nut tight in order to keep everything together underneath the mill. So I've got the belt here that's sized right for this. I measured the center to center distance some time ago and ordered a belt, and I think that's going to fit. Here's the motor on its bracket, and I'm hoping if I tip this forward, I got enough slack. Yeah, I can get that on there. And when I tighten it up, it's fairly tight, so that's going to work, I think. Let me get some nuts on here and washers. Probably can't see that behind this thing, but I'm just putting a couple of big washers on there and a couple of these flange nuts that you would use for holding down the strap clamps. I've got a line on here that I believe will give us the correct pulley alignment, but we'll see in a minute. I'll get even with this line here. I think we should be in the right place. Let me get the straight edge. Put that on the pulley. Yeah. Yeah, I think we're all right there. So I think we're lined up. We're going to tighten these up. My 7/8 wrench here. Okay, now we'll get the electronics box in here and power supply and stuff and start doing some hooking up. Here's our setup right now. The rotary table is set up with the tailstock, and that's been adjusted to be true, and the motor 2 is set up to drive the rotary table through this belt, and we have the power applied to the motors. Motor 1 here is set up to drive the table, the linear table, I guess you say, the mill table, and it also has power applied. And I added this board here to keep the cables under control and also provide strain relief. So that's ready to go. And then over here is my laptop running the ClearPath software, and we'll bring that up in a second and set up to tune the servos. That's the next step. Okay, the next step is tuning the servos. When you put a different load on the servo motors, the various feedback constants in the servo system change, and so you need to retune the servos. And with these motors, that's an automatic process. Under the setup menu on the ClearPath software is this auto tune set up, and that's what it's doing right now. The motor jumps back and forth and moves the table around a little bit and adjusts its constants, and in some mysterious way, and that's what's happening right now. You can see the, back up a little bit here. This is the motor. Got a cord kind of in the way there, but you can see the motor is turning the shaft a little bit at a time, making some, it's turning it really sharply because you can hear the slack picking up the backlash in the oh, there it goes a little further now. The backlash in the system, when it hits the limits of the backlash, you see it, you hear it make a click. We've added the our control box now to the system. Motors are still hooked up as you saw them, and they're both tuned now. We finished the tuning on both motors, and that took a few minutes, I don't know, 10 or 15 minutes for each one. And there's the other motor driving the table. And the control box is here, and it's connected to the motors with the blue cables that you can see here. And I have added some more tie wraps here to get the cables all under control. And we've if I plug this in, you'll see the screen lights up. It's a little hard to see on the camera, but it's basically the same information that we looked at before. And so we're set to go with this box. And the other thing that I did is I added the safety switch that I talked about before. The switches mount on a spot on the mill that was designed for a limit switch for the power feed mechanism, and I've taken that switch off and replaced it with my switches here. And these sliders are adjustable, so you can move them wherever you want them to be. And I've set one up here. This the table now is in the home position, which is as far to the right as you would ever expect it to be. And if it moves to the right a little bit, it'll shut itself off. And conversely, this slider here takes care of the opposite direction. And these already got tested, because when I first turned this on, the motor was turning the wrong way, and it immediately went to the safety switch and shut it off. So I know that works anyway. So so I guess we're ready to go, and the next thing I want to do is a dry run on this thing. Okay, we're set for a dry run here. The mill is cutter is not turning. We're just going to go through the dance with of all the motions to make sure that works right before we actually try to cut a gear. And the mill table is in its home position, and you can see on the DRO the x-axis, which is on the top, is reading 000. And the rotary table, I don't know if you're going to be able to see this or not, but I got a little mark on there on a piece of blue tape, and it's set for 270 degrees. And I can't read that real precisely, but if we get through the cutting of the gear and it comes back to 270 degrees, we'll know that we went through the full cycle. We've set the table move to 1 inch. The gear tooth count is 29. I'll explain that later, but that we're going to make a go through the motions of making a 29 tooth gear. Okay, here we go. We're pushing the green button. Okay, right away you see the table start to move towards us, which would be the direction that it would make for the cutter to engage the part. And now the table's moving back. Now we should see the table advance. There's the rotary table is turning now. And again, the table is moving the cutter past where the gear would be if we were actually running. It comes back again. Now you'll see the rotary table turn. Yep. There we go for the next tooth. So it is doing all the things it's supposed to. And it is counting down the number of teeth. I don't know again if you can read that or not, but it says there's 27 teeth yet to go. And so I'm going to let this run. We still got, I don't know, 8 or 10 teeth to go here, and but this thing is just fun to watch. I've been I just been gazing at it, and it's kind of peaceful here to watch this thing work. The clicking noise, by the way, is coming from the power feed on the mill. I turned the power off to it, obviously, but I did not disconnect it. So it's the gears in there make a little bit of a racket, but otherwise this thing would be completely silent. Okay, that's enough. Okay, we're down to one tooth to go, and making the last cutting motion here. We're returning. And we advance the cutter. We should stop here, which we have done. And now let's see how we did. Looking at the x-axis, we're 0.001, a thousandth of an inch off. I can live with that. And on the rotary table, we are back to 270 degrees, so I'm happy. Looks like we've gone through all the motions of cutting a complete gear, so I'm going to make up a new blank here, and then we'll get ready to actually cut a gear. Can't put it off any longer. Okay, now we're getting ready to cut the first gear. I decided I wanted to go with a 31 tooth gear, and I'll explain that once we get this finished and are checking it out. I have adjusted the cutter height to the center of the part as we did in part 1, and I have advanced or brought the work forward to where I touched off first, and then I brought the work forward 68 thousandths for the correct tooth depth, and I have set the tape x-axis table at its home position, and I guess I've set the table motion to 1 inch on my controller, and I've set the I've set the gear tooth count to 31, and I have the right diameter blank in there for a 31 tooth gear. So we're about to push the button here, see what happens. First, I think we better turn on the the mill here, otherwise we're not going to cut much. Okay, the mill is now on and set to just over 1,000 RPM, so let's try that again. Now I could go have a cup of coffee or take a nap or whatever, but I think maybe I'll stick around for this since this is the first year. Okay, so we missed the end of that. The camera was giving me a message that I interpreted as a low battery right in the middle of the cutting of the gear. So I actually halted the process with the halt button on my controller there, which worked okay. And I put the AC power out of the camera and started things up again, but that didn't help. What the message was really was, it was a little flashing icon that meant that my card was running out of space. And so we missed the end of it, but I gave you a speeded up version there towards the end. And here's the resulting gear coming off the and once again, it looks pretty good. I can't see anything wrong with it. The teeth all look the same. And actually, I made a little gear tester. The reason I made this a 31, or I was going to make a 29 or a 31 tooth gear, and the reason I picked that was that I wanted to run it up against the 30 tooth gear that I had made by hand, and I got a little mark on there, and you can see that if I adjust this right, they mesh really well. And if I started out here with the two marks coincidental, and if I go around the thing once, we're now one tooth off, this being the 30 tooth and this the 31 tooth, and of course if I go around again, we're 2 teeth off. So everything came out the way it's supposed to. They mesh really nice. I'm happy with the outcome. The only thing that bothers me a little is I'm not sure that I like the shape of the teeth. To me, the crown of the gear tooth looks a little wider than the root, and I don't know why that is. Off the top of my head, I think the you know, I've gone over the equations over and over again and from multiple sources, so I'm sure that I've set the dimensions right. I'm wondering about the gear cutters that I have. They're you know, the lowest price ones I could find on eBay, so I'm not sure that they're I may end up having to get a better set of gear cutters. I don't know, but these gear cutters come in sets of 8, and one of the problems is that the old standard was the lowest numbered ones were one end for the smallest gears, and the highest numbered ones were for the gears with the largest number of teeth. But some manufacturers in other countries use the opposite sense, and so I may be in the wrong. I may have the wrong cutter, or I may have a not satisfactory set of cutters. But anyway, we'll get to the bottom of that, and the next thing we're going to do is make a lot more gears, and then we'll start a we may have one more video on this if I discover some things about the gears that I didn't know, but otherwise we're going to be starting a new series of videos on the harmonic analyzer itself, and we'll talk more about that at that time. So thanks a lot for watching, and we'll see you real soon.